All right, integrated 3 students. We are continuing with logarithms. We got 2 ideas that we're going to really cover today. We're going to look at some more examples involving these logarithms, and then we're also going to be talking about solving exponential equations that have common basis. So that we're going to, and we'll probably come back to logarithms again in the future. But let's go ahead and look at some more ideas over logarithms. Okay, so I have added a few more sections into the Delta Math, and we are going to start looking at these. So last week's lessons, I had added these solving exponential equations, okay? And you used a logarithm to do that. Now, on your next test, not only do you need to be able to do that, but you also need to be able to convert between the forms without any issues. Okay, so if we are going to say you have this here, it says write the log equation as an exponential equation. You don't have to solve for anything, you just need to rewrite this. So I'm going to work this problem out, and we do need to remember our formula for converting the logarithm, which is this one right here. Okay, so we're in this one, we're going from a log to an exponential. So I'm kind of working my way backwards. So I know that this is going to be the base. So I'm going to do this. So the base is going to be 4. The exponent is going to be what's on the right side. So this is 4 to the 5x. Then we're going to put the equal sign, and it equals what's inside of this parenthesis. So it's 5x plus 2. And that's the answer to the question. 4 to the 5x equals 5x plus 2. You don't have to solve this this problem. It's not one that we're going to solve. It's just practicing going between the forms. So 4 to the 5x, and you put an equal sign, 5x plus 2, hit enter, and we're done. Okay, this is just a very quick practice for this. Now, let's talk about natural log. Remember, natural log, we had our logarithm FYIs. Okay, remember that natural log is equal to log base E is what that is. So that's important. It is, we can rewrite it like this, and if it helps you, you're able to do this. Log base E of 2x equals 2. So that's very important to remember that. Natural log, ln, is log base E. And remember that log by itself is log base 10. So I'm going to give you plenty of questions on here to make sure you see different examples. But let's go ahead and rewrite this. This is going to be base E to the, we're going to raise it to the 2. Again, I'll put in let's paste in our formula here. So the x, whatever's on the right side, goes up to the exponent. So this is 2 equals 2x. So e to the 2 equals 2x. Let's go to Delta Math. Let's type that in, e. So you can just use e. It'll know, put that there. E to the 2 equals 2x. Hit enter, and we got it. Okay. Lots of problems here. You're just converting. No solving happening. Nothing like that. Okay. Next, we have this logarithmic form. Here, you're given the log equation, and you need to solve for x in whatever way you need to do it. Now, obviously, we have to change this because there's no way on your calculator that you're going to be able to type in an x to get an answer. Okay, if I put x512, it doesn't work. And I don't know why my computer's even reading anything. Let me start a new document here. Calculator. If I do log base x of 512, it's not defined. It's impossible to do this. So actually, we need to, oh wait, what? Undo. Oh, okay, hold on. I didn't actually write on this. We need to paste in, we'll get our formula here. Okay. We have to convert this to an exponential. So here's where using that exponential is important. It is x to the 3 equals 512. Okay, now how do we get x by itself? This goes back to older skills. How do we get rid of the 3 inverse operations? We cube root, right? Cube rooting that. So we need to do the cube root of 512, which we can see is 8. So we're going to put, so that's x equals 8 on here. So let's go ahead and try that. Not 89, 8. There we go. So you're going to have several questions where you're solving for whatever you need to solve for, and you just need to see, sometimes you don't need to convert it. For instance, you don't need to convert anything here. To answer a question like this, I'm just going to do log base 4 of 64, and it gets you the answer. It's 3. So I just type in a 3. That's all you have to do. Okay, so you're looking for questions like that. So that's you have 6 of those. Let me actually make this 8 here, because I just want to make sure you have plenty of variety. Those don't take long. All right, now we want to talk about this last one. This is going to be our the last part of this video. So this is going to be a pretty brief video, ideally. Exponential equations with common bases. Okay, so I want you to check this out. This is using a little bit of those exponent rules, and for these problems you're not going to be using a logarithm. The problem with it is that both sides have exponents, but there's a reason they call it common bases. So whenever you're working these questions, both sections, you're looking at the bases, and you'll notice that they're called common bases, and you'll be looking for those, and you can convert them into the same number. Okay, so let's talk about that. What is the common base that these have? Meaning, what number could I raise to a power to get each of these? Well, I know that 2 to the second power equals 4. Can I raise 2 to a power to get 64? So let's raise 2 to the third. That gets me 8. That doesn't work. Let's go back up. Let's make it 2 to the fourth. 16, 2 to the fifth, 32, 2 to the sixth, I get 64, okay? And I know 2 to the second is 4. So we're gonna rewrite both of these like this. And this is the idea and the concept that I wanna show you guys today. So whenever I look at these numbers, I'm looking for a common number that I can raise to a power. So this is gonna be 2 to the sixth to the x plus 3 equals 2 to the second x minus 1. All right, so we have converted the numbers, and that's going to be the first step for all of these, is create the common base. Find the number that I can raise to a power to where they are the same. Now, next, we are going to simplify the exponents. Let me actually write out these steps for you guys. And in your notes, you should actually write this, right? Exponential equations with common base. So step 1, create the common base. Step 2, simplify exponents. So this is our second step. We want to simplify these exponents. Well, what do I mean by that? Well, I want to combine these. What is the exponent rule for when I have a power raised to another power? Well, you can multiply these. So this becomes 2 to the 6 times x plus 3, 2 to the 2 times x minus 1. So I'm multiplying these exponents. Now I need to distribute this in. So we're going to write this again. 2 to the 6x plus 18 equals 2 to the 2x minus 2. Okay, there's our step 2 here, the simplifying the exponents. Now, in order for us to solve this question, we're trying to get x equals at the end of this. We notice that these bases are already the same. So if we like take these away, all we have to do is show that these exponents are equal to each other, right? If I can show that this exponent equals this exponent, then I can solve this problem. I can find x. So once we have the exponents simplified, we're going to set the exponents equal to one another. So that's our last step that you're going to write down in your notes. So this is what that looks like. Or we'll even say it this way: drop the bases. If you will, like if you imagine, okay, we don't care about the bases anymore. We know they're the same. Let's set these exponents equal to each other. So it's 6x plus 18 equals 2x minus 2. Now it's a two-step equation. This is middle school math here, or actually freshman year math. I'm going to move the 2x over to the left. I'm going to move the 18 over to the right through inverse operations. This goes away, this goes away. We get 4x equals, this is going to be negative 20. Time to divide the 4 away from both sides. This goes away. X is equal to negative 20 over 4, so that's negative 5. I don't need to check anything here. That should be the value that works as an exponent for these problems. So we're going to type negative 5 in. And we got it correct. Now they will show these same steps. You'll notice that there's multiple ways to do this. They found the common base was 4 instead of 2 like I did. So they didn't have as complex as a solution, but you'll see here, rewrite with the common base, distribute the powers, or I said simplify the exponents, set the exponents equal, solve for x. That's going to be the process that we use here for all of these. So here we'll find a common base. I'll work this one really quick. Common base is going to be, it looks like 5. So 5 raised to what power equals 125? Well, let's do 5 to the second is 25. 5 to the third is 125. Okay, so let's rewrite this. 5 to the x plus 5 equals 5 to the third to the negative 1. Exponent, now we simplify these, so we're going to multiply the negative 1 times the 3, so it's 5x plus 5 equals 5 negative 3. And, so now we're ready to drop those bases, or just set the exponents equal. X plus 5 equals negative 3, and you may already be able to solve this without much trouble at all. You're just going to subtract 5. X equals negative 8. Okay. All right, so that's another way to solve for a few of these exponents. If we only had one exponent here, though, we would use a logarithm to help us out. Okay, or if we don't have a common base, we can't really even do this. We would need a logarithm if we don't have a common base. So this all is revolving around the fact that we have common bases. Let's look at one of the level 3 questions here. So the difficulty of this question is we have fractions. So we have to think a little bit more. Also, looks like there's going to be some quadratics in here. So we are going to work one of these, and then I'm pretty much going to be done with this. This is a pretty quick lesson. So let's look at this. Hold on, I need to recopy that. Okay. So how can I get 10 and 1 over 100? That's what we want. Okay. So really, anytime you have a fraction, you want to change it from a fraction to the base that's here. So how can I make 1 over 100 equal to 10? Well, 10 to what power equals 1 over 100? 10 to the 2 is actually 100. And remember, if we want to make a fraction, we need negative exponents. So let's do this. Let's do 10 to the negative 1. That's 1/10. 10 to the negative 2 is 1 over 100. So I know that I can rewrite this one right here as this. So we're going to do 10 to the 2x squared minus 6 equals 10 to the negative 2 times 4x minus 2. So that's, hopefully that conversion makes sense. This is why this is level 3. You're looking at these fractions. Remember, anytime you see a fraction, that is something raised to a negative power. And that's what we're trying to practice here, okay? Anytime you have a negative power, that's a fraction. So now we need to simplify the exponents. Nothing to do on the left side. So I'm going to leave that like that. Over here, we're going to multiply these. So I'm distributing this -2 to both of them. I'm just going to go ahead and skip to that step. So this is 8x plus 4. Now we're going to set the powers equal to each other. 2x squared minus 6 equals 8x plus 4. Here's what's more difficult about this problem is that we see a quadratic. So we're going to have to solve the quadratic. So let me show you. Let's hopefully refresh on this. We're going to move 8x over, move the 4. We're going to move it all to the left side. We want to keep this positive. So minus 8x minus 4. These go away. That's 0. The only like terms are the 6 and the -4. This 2x squared stays as 2x squared. And then we're going to minus 8x and then minus 10. All right, so how do we solve the quadratic? Well, we can use quadratic formula, or what we did a lot of this year was solving by factoring. And what I see first here is a GCF. What's the GCF of these three numbers? It's 2, right? So let's take a GCF of 2 out. So 2x squared minus 4x minus 5. Okay. There's our first part of this factoring process. Now, inside of here, we have the factor the quadratic. And if we take that -5, the factors are 1 and 5. Which ones add to get -4? Well, it's -5 here. So we're going to do 2 times x plus 1, x minus 5. So we're using all the skills that we have for algebra to do these problems here. So we get our final zeros, x equals and x equals. Remember, we have to change the signs of these, so it's -1 and 5. So here's our answers to the question. Let's go back to Delta Math and see how they want us to type that in. We know that we're going to need an extra one, so we want is it -1 and +5. Either of those work just because it's a quadratic. Make sure I got that right. Yeah. Got it. Okay. And obviously you can watch the steps here. If you need more clarity on this and you need a little extra help, let me know. These problems should not be taking you 30 seconds. They should take longer. Okay. They should take a while because there's a lot of steps within it. But make sure that you follow these steps, get the common base, simplify the powers, equal the exponents, and solve it. Once you get to this step, you shouldn't have, I mean, maybe you need a little refresher, but you know how to do all of the steps when you set this equal. You're not going to run anything more difficult than that right there, okay? All right, so that's going to be it for this video. Go ahead and make sure that you start working on the assignment. And if you have questions, make sure you reach out to me.